Welcome to our maths. Today we're gonna do modes. So AB is a uniform one of mass 4 kilograms and 2 meters. So we can already put 0.8 around the middle of the hair. So 4G, and this should be 0.1, since the whole length is whole length is 1.2, and the length from here to here is 0.5 meters, 0.1 meters here. And we know that there are two vertical wires attached 0.8 meters apart, point A and C. C is 0.3 meters A, shown in the diagram below. Particle mass m kilograms is attached to the point A, B, point E, such that A, B remains in horizontal equilibrium and the tensions of Y, C, and D are equal. Given that the point E is in points between points D and B, show that 0.8 is less than ME, and ME is less than 1. So in other words, it's between 0.8 and 1. And we know that E would reside between D and B. So let's draw put ME here. ME is the point E, and it's a distance D away from D. And since D is between 0.1, we know that it definitely is greater than 0 and is less than 0.1. So this is the point D and B. It's not exactly at D, or it's not exactly at B. Now we know from here to here is 0.3, since it's in the middle. And that's all you need for the question at the moment. Now, since the equilibrium, the tensions equal the weights. So we know that the weight here is 4G, and we know that the weight between D and B is ME G. And we know T equals TD, who we can represent both forces as T, since they're both equal. So T plus t. Substitute t into equation. 2t equals 4g plus meg and 2t equals 2g is half meg. And let's take the tensions at C. And that's just C all the way to, from the force C all the way to B. So know the distance from C to B is 0.9. So it should be the force tension. So when taking point B, we're gonna say clockwise equals to anti-clockwise. Since they're both in equilibrium, so the anti-clockwise and the clockwise forces should be equal. So tension C is 0.9 because we got the force GC, got the distance from C to B, which is 0.9. And that also goes clockwise. So in clockwise on the left hand side. And from here, from D to B, it's clockwise again. And that distance from D to B is 0.1. Which would be equal to the anti-clockwise on the right hand side, so 4g times 0.6 and meg times d. Plus meg times d. So that equals 0.9 Tc plus 0.1 Td, which equals to 2.4 G plus d mg, since we simplified it and we multiplied. And now that tension, we can represent both forces as T. So 0.9 T, 0.1 T equals 2.4 G plus dmg eg. So T equals 2.4 G plus dmg. And since we know T already, we can make both values of T. We can make a simultaneous equation and substitute 2G plus half meg into the unknown value T at this moment. 2 so 2 G plus half meg G equals 2.4 G plus d meg. So G is common to all the values, so we can cancel that out. 2 2. Let's multiply f by 2. ME minus 0.8. Oh yeah, so we multiply by 2dme. By got to multiply by 2, so that's a mistake that you have to watch on. So me minus 0.8. We factorize 2me out to get d on its own. And we want to find d, because that gives us the distance of me. Divide by 2me equals d. So following on from 0, d is between d 0 and 0.1. 0 between me minus 0.8 to me equals 0.1. So let's split this into two parts. me 0.8 to me 0.1 is less than 0.1, so me minus 0.8, and we're going to multiply everything by 2me. So 0, that gets rid of this fraction, and that multiplies 0.1 times by 2me. So 0.2me is here. And we say me minus 2me is 0.8 is 0 since it's less than is less than 0 since we moved it onto the other side. Now we say 2me and we put 0.8 on the other side. So 0.2, sorry. Me, factorize me out, so me was 1 minus 0.2. Me 0.8, 1 minus 0.2. Me is less than 1. Now we need to work out this. And so, look out this side. 2 ME, 0 is less than ME, 0.8, multiplied by 2ME here to get rid of the fraction, and 0.8 is less than ME. So let's combine these. When we combine these, we get 0.8 is less than ME, and ME is less than